Here's an explanation for question number 28 in the final exam for Teach Yourself Electricity and Electronics, edition number 5. Please refer to page 667. The question asks us about a circuit that contains a DC voltage and several resistances or elements, circuit elements, which we denote here as resistors. We'll represent the DC voltage source as E, as a battery. Each one of these elements or resistances has a particular voltage across it. E sub 1, E sub 2, E sub 3, and E sub 4. Here we can follow the current as an electron flow going from minus to plus. So each one of these components will have a polarity in the voltage that appears across it. The negative side of the component will always be closer to the negative terminal of the battery, and the positive side of the component will always be closer to the positive side of the battery. Just as an aside, not that it's particularly relevant here, but it is something worth knowing. Conventional current, that is to say, the current as it was originally expressed by physicists before they knew about electron flow or anything like that, went from plus to minus. It was an arbitrary set of poles that they decided upon. They just decided that one particular type of charge would be called plus and one would be called minus, and the current would go from plus to minus, which makes reasonable sense. As things turned out, the plus that they originally decided upon represented a lack of electrons, which are the primary charge carriers in most circuits. So when you hear about conventional current going from plus to minus, that's kind of a historical artifact. But the question asks us, if we take these polarities into account and add up all of these voltages, all 5 of them in this example, what will we get? And the answer is that we will get 0. We will get 0 if we take polarity into account. Now, if we don't take polarity into account, if we just measure the voltages and don't worry about which side is plus and which side is minus, then we get absolute numbers for all of the voltages, just plain ordinary positive numbers. In that case, E1 plus E2 plus E3 plus E4 would equal the battery voltage. But this question asks us specifically to take polarity into account. And when we do that, in effect, we go all the way around the circuit from any particular point back to that same point. We always get 0. One trivial way of looking at that is that any particular point in the circuit, say it be here, call it point P. If we go all the way around the circuit and take polarity into account when we measure each voltage, we're going to end up measuring the voltage of P, point P, with respect to itself. That can never be anything but 0. If it were anything other than 0, I guess we'd be living in an alternative universe of some kind. Anyway, the correct answer to this question number 28 is E, as in echo. The voltage, taking polarity into account, E as in echo, it is 0.